Hi everyone, this is Miss Sydney. Yesterday I did a live in Facebook, and I didn't manage to finish it because the phone ran out of battery. So this video clip will be focusing just 3 questions on how to solve the Earth as a sphere in SPM. Now let's start. Now this question, P and Q are 2 points on the surface of the Earth, such that PQ is the diameter of the Earth. Now, before we solve the question, it's always good to illustrate the Earth so that it's easier for us to solve the question. Now, it's either you draw using the 50-cent coin, or you use the compasses to draw the Earth. Now, with that, the next part will be, okay, we draw it's like axis. We draw the horizontal line. Okay, this is the diameter of the sphere. Okay, it's not sphere yet, still circle. So it's this two, it's like x-axis and y-axis, so that we will know exactly the point where our center of the Earth is, and this is the North Pole and this is the South Pole. Now let's make it more 3D by joining these two ends, okay, with the curvy line. Then it will automatically become 3D. Now next, we need to mark down the point P. Now PQ are diameter, so they have to be on the opposite end on our Earth. So in this case, our P is at the southern hemisphere, so I should draw it downwards over here. So it's here. So let me mark down this to be our point P. Okay, now the position of P is such that it is 50 degrees south, so 50 degrees south, and it is at 120 degree east. Now make it a habit that you mark down your latitude and longitude this way. Latitude put at the side, don't write in the middle, and the longitude also you draw the longitude and then the arrow and put down here. And we know that the PQ joining together form the diameter, so let's draw the diameter. Okay, and passing through the center of the Earth. That is called the diameter of the Earth. Now, if this is P, therefore this one must be Q. Alright, so these are the things that we know. And what else do we know? Now, since this is 50 degree south, actually how we measure this 50 degree, we measure from the diameter of the Earth, the equator over here, because equator is our 0. So you imagine from here, then you go down, so this will be 50 degree. Now if this is 50 degree, that means this is also 50 lah, right? If you join from here to here, this is also 50. All right, this is 50. Now this is a straight line, isn't it? PQ is the diameter straight line. Therefore, the diameter of the Earth that passing through the equator is also straight line. Therefore, we will have a vertically opposite angle. This is also 50. So we already found where is our Q. So let's draw this one. The diameter of the parallel whereby the Q are located. So this is also 50 degree north. Okay? And what else do we know about this diagram? So you see this one is 120 degree east, and they are actually at the opposite end. So the distance between these two meridian is 180 degree apart. So if this is 120 degree east, therefore this side will be 180 minus 120. Okay, if this is east, this one will be west. Okay, it's like formula. So if this is east, this will be west, and 180 minus 120, so we will have this side to be 60 degree west. And with that, we can answer our first part of the question, that is, state the latitude of Q. The latitude of Q we have just drawn. Okay, the first part, latitude of Q equals to 50 degree north. Okay, and the second part, given that PR is the diameter of parallel latitude. Okay, PR is the diameter of the parallel latitude. That means it's here from P joined to the opposite side, because that will be the diameter of our, this is called the parallel of latitude. So the R will be here. If the R is here, so what is the location of R? When we talk about the location, we always say north-south and then east-west. So in this case, it's at southern hemisphere, so it will be 50 degrees south and it is 60 degree west. So we have found the position of our R. Next part, calculate the shortest distance. Sorry, it's over here. Calculate the shortest distance in nautical miles from P to R. Now, the shortest distance will always be along the great circle. In this case, how do we move from P to R through the great circle? That will be flying through the South Pole. This will be the shortest distance as compared to the PR, like that. You can actually prove it by calculating, finding the distance between the PR along the parallel of latitude. But in this case, that one you can do it and then you show me and then send to me at the comment area. Then I will give you the feedback. So in this case, we need to find, how do we find the distance of PR? That will be theta times 60 nautical miles, right? Nautical miles. Now, the angle over here will be the angle that subtended by this arc, that will be in between this. Now, we know that this is 50 and this side is also 50 because this is a straight line. Total angle is 180. So 50, 50 taken away from 180, we're left with 80 degree in here. And therefore, the distance between P and R, okay, it will be 80 degree times 60 in nautical miles. We will have 4,800 nautical miles. That will be our answer. Okay, so with that, we can go to the next part of the question. That is, an aeroplane took off from P. Okay, aeroplane is here and flew due west. It will move due west. That means it moved towards the R. Okay, it moved due west in this way. And it took, the speed is 600 knots and the time taken is 2 hours to reach the T. So the part D, we have the speed 600 knots. Put down the information and the time is 2 hours. And we need to find the distance, right, of PT. How do we find? So to solve this question, you need to know this, the golden triangle. Dolly the ship. Alright, I already mentioned in my live, where you can just refresh it. I put the link down at the comment area, at the description area. So this D, what is D was T was S. You want to find D. D stands for distance. Therefore, to find the distance, we just take time the speed. So in this case, the time is 2 hours and the speed is 600. And distance will be automatically in the unit of nautical miles. Okay, so we will have the distance between the P and T is 1,200 nautical miles. Okay, so we have done the part D. Now, next, the longitude of T. How do we find the longitude of T? Now let's look at this. It's only 1,200 nautical miles. That means our T could be somewhere here. And we need to find the longitude whereby the T reside. Okay, the T is over here. So we need to find the distance between the P and the T. Now you notice that PT is actually along the parallel of latitude. So the distance will be smaller than the great circle. So in order to find the distance along the parallel of latitude, the formula will be different, yeah? Will be different. So this is part 1 just now. So part 2, the distance of PT is equivalent to the theta, the angle between the P and the T here, and we need to times 60. This is the formula to find the distance along the great circle, but because this is smaller than the great circle, cos of the 50 degrees south, so we have to times that 50 degree. It is smaller because it's not the great circle, it's along the 50 degrees south, so it will be theta times 60, smaller because of 50 degree. You can remember this way. This is the formula anyway. All right, now therefore this is the information that we have, and PT we already found, so let's put it in so that we can find the value of theta. So with this one you have to count. To find theta, that will be 1,200 divided by 60 cos 50 degree. So this one you use the calculator and you should get 31.11 degree. So with that, okay, with this, we know that if this is P, which is at 100 degree east, and the T is due west, it's at the west, and the difference between them is 31.11 degree. So what we need to do to find the position of T, it will be 31.11 degree less than 120 degrees. So we have to take 120 minus this, and therefore we got this one, 88. Now you can change it to the minute if you want. Do you know how to change? 53. Okay, basically it's like this. Where's my calculator? Okay, so we will have 120 degree minus 31.11. So we have 88.89, right? So you press this button. You see this button with degree, minute, and second. Press this button. Then you will have 88 degree and 53 minutes. Now this one, if it is more than 30, then you carry forward lah, because every minute is 60 seconds. So as long as you more than half of that, then you carry forward. But this one is less than 30, so it will be just 53 minutes. So you will have 88 degree, 53 minutes. Therefore, the longitude, let's answer the question. Longitude of T, it will be 88 degree 53 minute east. That's it. Okay, for this question, in this diagram, the 4 points are given on the Earth of the surface, and whereby PQ is the diameter of parallel of latitude of 40 degree north. Now, X lies, okay, these are the information that you can fill in this in a diagram given. But for me, I will redraw here because should anything happen, then I still have a very clean original diagram for me to scribble. For you, you may not need to do so lah. So let me reconstruct this diagram. Yeah, give me a second. Now to reconstruct this diagram, what is important is we need to have the diameter line, the diameter that is horizontal, as well as vertical, that pass through the center of the Earth. Okay, we mark down that this is the center of the Earth. This one will give us the north, this one will give us the south, and these two ends will be joined together we will have the equator. So now the whole circle become 3D, the ball shape, the sphere. Then what other important information? Just now we will have this line, the parallel of latitude. Okay, and for this parallel of latitude, it has its own diameter as well. And this will be the center of the parallel of latitude. That's why drawing this horizontal and vertical line that passes through the center of the sphere is very important. Now, what other information? Okay, we have another longitude over here. And this is the R. This is the P. Okay, and we have over here, from here to here, it's given as, here it's given as 120 degree. Okay, now what else? We have a point X over there. Here, this is the X. All right, now let's fill up the important information. It says that P is 40 degree north. So this is 40 degree north. 40 degree north. What am I writing? 40 degree north. Okay. And 58 degree west. So let's mark down the longitude at the bottom here. Okay. Longitude here. Make it a habit. 58 degree west. So if this is 58 degree west, so this side, the opposite end, they will be 180 degree apart. So we take 180 degree minus 58 degree. If this side is west, the opposite side will be east. It's always like that. It is always. So 180 minus 58, we will have 122 degree east. Okay, any more information? Okay, the question also says that X lies 3,780 nautical miles due south. That means X is actually at the southern of R. So we will have another information. Rx is 3,780 nautical miles. Now Rx is the longitude, and we know that longitude is actually the great circle. Yeah. Okay, let's answer the question right away. Now, first, part A. Part 1, we need to state the longitude of R. Longitude of R, and that will be, where is R? R is over here. Okay, the R is actually 120 degree away from the 58. Okay, so we take, you see, we use this. This is the Greenwich meridian. This is 58 degree west. And we know that from here to here is 58 degree. Okay, and we want it to be 120 degree apart. So what is this? What should we add so that we get? Because from here to here is supposed to be 120. Okay, so we take 120 minus 58. We will have 62 degree. Okay, 62 degree because it's on the right side of the Greenwich meridian. Therefore, this one will be 62 degree east. Double check. Yep. So the longitude of the R will be 62 degree east. That's the answer for the longitude of R. Next, we need to state the location of Q. So the location of Q, we have to mention the northern or the southern part of the hemisphere. So where is our Q? Q is actually, according to the question, it says that PQ is the diameter. So this is Q over here. So our Q is there. So what is the position of the Q? So it's at the 40 degree north. and it is at the 122 degree east. So this is our answer. Okay, so we have done the first part A. Next, let's go to part B. Now, part B, we need to calculate the shortest distance in nautical miles from P to Q, measured along the surface of the Earth. Now, the shortest distance is always passing through the Great Circle. In this case, it's either you pass through the North Pole or you pass through the South Pole. In this case, it's North Pole lah. Okay, the question is always in such the way. So we need to find the distance from P to Q along this great circle. So it's like calculating the arc length of the circle. So we find out what is the angle subtended by this arc. So we join to the center of the sphere, and you know that from here, this is 40 degree north. So it will be 40 here, and this side will be also 40. So if this is 40, this is 40, therefore the angle that's subtended by this arc will be 180 minus 40, 40, so we will have 100 degree over here. Therefore, to find the shortest distance of PQ, B, shortest PQ, it will be 100 times 60 nautical miles. So we will have 6,000 nautical miles. All right. Now the next part, the question says, calculate the distance of PR measured along the common parallel of latitude. So where's PR? PR is at the longitude. 40 degree now. So this is the one. So we need to find the angle between the P and the R. And it is the same as the angle here because they are measuring along the same longitude. So it's 120. This is also 120. But however, it's not the great circle. That is why it is much shorter. So when we use the formula, it cannot be theta times 60. We need to times the factor that causes it shorter. So CPR, it will be 120 degree times 60, and the factor will be cos 40 degree. So with this, you press your calculator, we have 5,515.52 nautical miles. Okay, so we have found the distance of PR. Now, next, the questions say, the part D, an aeroplane took off from P and flew due east to R. So from P, flew due east to R, yeah? That means from P, you fly due east over here. Okay, and then it says, after that, flew due south to X. After that, coming down here, you flew due east and then due south. Okay, and then the average speed for the whole flight was 680 knots. So we need to find the time taken for the whole flight. Okay, part D. We have the speed. This is the average speed. It is 680 knots. And then we need to find the, if you have average speed, you must have total distance. Do we have? And our job is to find the total time taken. This is the one that we need to find. Again, we use the dolly the ship. Dolly the ship. We have the speed. We need to find the time. This is the one that we need to find. So we must have distance. We must have the speed. Speed we do have, but the total distance, do we have the distance of PR in the first place? Because these are the path. PR. Do I have the PR? Do we have the PR? Yes, PR is found. It's over here. Therefore, we have to take this one, 5,515.52 plus, don't forget, we need to plus the distance of Rx. Rx is given, isn't it, over here? So 3780. So plus 3780. So we have this, we have this. Now we can find the total time taken. Total time is total distance. So the total distance is 9. This one, when you add up, you will have 9,295.52 divided by the speed. The speed is 680. And the time should be in hour. There we go. 13.67 hours. Just leave your answer in this format. Then you get all the 12 marks over here. Okay? That's it for this question. For this part of the question, a diagram is not given, so we have to draw our own Earth. Yeah. So as I said, you can use the compasses to draw, or you can use the 50-cent coin, but 50-cent coin is a bit too small. So we use the compasses so that we can draw a very comfortable circle as big as you like. And then the next step is to construct the horizontal line, the diameter, horizontal diameter, and the vertical diameter, because these diameter will help us to mark down our north, south pole, the center of the earth, and also our equator. So with this, so it will make the flat 2D circle become a 3D sphere. Next, let's put in the information. We have J. Okay, J is 40° north and 70° west. And then we have K and a L and a M, 80° south and 110° east. There are 4 points on the earth of the surface, whereby K, L, they are the diameter of the earth. That means they are right at the opposite end of the earth. Okay, whereby J to K is the diameter of parallel of latitude. That this is the shorter diameter of the shorter circle. Okay, so with this, we need to state the position of L. Let's put this information into our diagram first. Where is J? Now, you will notice that J and the M at the longitude, one is 70° west, one is 110° east, and then we have KL, diameter of the earth, yeah? And J to K. Okay, so let's put down that this one. Always use the great circle. So I will mark down, since the J and M, they are opposite to each other along the great circle. You notice that 70 plus the 110 is 180. So they are 180° apart. So let it be on the circle that we have drawn. So this is called 70° west, and therefore this side of longitude will be 110° east, because these two add up will be 180. And J is at 40° north. So let's draw the 40° north. Okay, let it be here. This is the diameter of the parallel of latitude. So this will be the latitude. And this is 40° north. And this point is our J. And then the M is 80° south at 110° east over here. So let it be over this side. So this is my parallel of latitude. This is the M because it is 80° south. Okay. Make it 3D. Okay, and what else? It say KL is the diameter of the earth. Now, I do not have K and L, but I don't know where to mark because it can be anything that as long as pass through the center of the circle, center of the earth. But over here I have J to K is the diameter of latitude. That means this one, J and K, is the diameter of this latitude. So my K will be here. If K is here, diameter of the earth will pass through the center of the earth. So we will join this way, like this. So this point will be our L. Oopsie, I think my illustration not so accurate because it happened to fall into here, but actually it's not there. Okay, I should have drawn this one slightly below. Okay, never mind. So over here we know that this one is 40 degree. That means we measure from the diameter here. This is 40 degree. If this is 40, this is also 40 because it's vertically opposite angle. So if this is 40, therefore this side, this is another parallel of latitude. It should be this one. It should be 40 degrees south. Okay. Now, so next we have to state the position of L. So if this is K, this is L. So position of L will be, so first part, position of L. So position will be the longitude and the latitude. We have to mention the latitude first, the north-south first. So L is here. It's at the 40 degrees south and it's along the same longitude as J. So that will be 70 degrees west. Okay, next part. We need to calculate the shortest distance from L to M. From L to M. So part B, L to M. Where's LM, yeah? L is here, M is here. That means we are actually looking for, you see the keyword shortest distance. It's always passing through the pole, either South Pole or North Pole. In this case, it's the South Pole. And we have to measure the angle in between them. Now for M, let's join to M. Now M is 80 degrees south, 80 degrees south. Therefore, this one is 80 degree. And from the L, the latitude of L is 40 degrees south. So this is 40. So the angle between this arc will be 180 minus 80 minus 40. So we will have 60 over here. Therefore, the shortest distance between the LM, B, shortest LM will be along the great circle. So 60 degree times 60 nautical miles. That will be 3,600 nautical miles. Next. An aeroplane flew from J due east to K. Okay, let's find out where is it. From J due east to K. So this one will fly like that. Then flew due south to M. Then fly like this to M. Okay, if the time taken for the journey is 31 hours, we need to calculate the average speed. So let's put down the information, yeah? We need to find the speed. So part C, we need to find the average speed. And we have the total time. That is 31 hours. That means we must have the total distance. Because according to the dolly, the ship, if we want to find the average speed, we must have distance, we must have time. Time we have, distance we don't have. So we have to find the total distance. So the total distance, basically, look at the red light. We have to, the red line, we have to have JK and KM. So the total distance will be JK plus km. Do we have j to k? We don't have. We have to find. What about k to m? Also don't have. We have to find. So let's find it. Okay, how do we find j to k? So that you can see. Now, from j to k, it's actually 180 degree apart. So we should take 180 times 60 nautical miles. But because it's not the great circle, it's much smaller than the great circle. So we have to multiply with the factor cos 40. Because they're at the 40 degree north, that is the factor that caused this to be shorter, okay, than the great circle. That's why 180 times 60, still very small because of 40 degree at the position of 40 degree north. So this is how we find the JK. And at the same time, we find the KM. Now, km is along the longitude, yeah? So this is the great circle. So we have to find the angle between the k and the m. So we have 40 from the 0 here. This is the equator. Equator is the 0 degree. So from the 0 go up 40 degree up. And from the 0 to m, which is 80 degree downwards. Therefore, the angle between them is 120 degree because you take 40 plus 80 times 60. That's it, because it's a great circle. So we will have 7,200 nautical miles for km. And as for jk, we have, let's count. Yeah? As for jk, we have 180 times 60. Don't forget to times the factor. Because of its position at 40 degree north, we have 8273.3. Yeah? 8273 point, okay, just put 28, round it up. Okay, and therefore to find the total average speed according to the formula, total distance, so we take this plus this, 8273.28 plus 7200 divided by the total time, which is 31 hours, and that will give us in the unit of knot. Okay, so take this plus 7200, oopsie, wait, 8273.28 plus 7200, and then total divided by 31. Okay, we have 499.1 knots. So that is the answer. Maybe round off to 2 decimal places. Or you want to leave it like this also can, for significant figure. If you want, you can put like this. All right, both we accept, yeah, the answer. So that's it. That's how we find the solution for the question. So all in all, what is important in this formula, in this chapter, is the formula 60, the theta times 60 to find the nautical miles. That is for great circle. And theta times 60, if it is not the great circle, we have to times the factor cos of what? The position of the north or south, okay, of the latitude. And also the leadership. And the unit for distance is nautical miles. The unit for the speed is knots. That's it. Okay, thank you.